the big thing in the last 10 or 20 years with AI is this statistical aspect of things. And it's just like how your brain has two sides. You have the logic sort of reasoning side and you have the intuitive side. And the two come together, and there's certain problems that one side does better, certain problems that the other side does better. The side that's more emotional will be good at things like a baseball is coming to you at 95 miles an hour and you need to hit that baseball, or you need to react in a split second, or you need to say, oh, that reminds me of this other thing. Whereas the logic and reasoning has to do with math, has to do with logic, has to do with piecing things together. And oh, that causes that, or if I do that, then that leads to these two other things, or that thing, then there's these three other possible ways that could have led to this thing. So both are useful for solving different types of problems. And more recent AI is how do we have that intuitive component? So self-driving cars are a really good example. And these are called neural nets. And they're based off of how neurons interconnect in the brain, where it's just sort of a mesh. It's sort of a very ball of yarn kind of thing. Like there's just all these interconnections, and they basically come together to, I don't have a good way of explaining it in the moment, but they form statistical patterns, kind of like how ants on the floor of the jungle, they'll naturally find paths on the lower or clearer areas, and then they'll use those as sort of little superhighways. So your brain finds those kind of things and creates statistical patterns. And so neural nets are just an equivalent to that. And so we may come to this later. The kind of human side that I focus on with accelerated learning is called intelligence augmentation. So it's kind of the reverse of AI. And it's about taking the innovations of AI and bringing those into how do humans learn? How can humans think better, think more clearly? So we can come back to that later, but with AI, it's really a form of psychology. It's a form of formalized psychology where you're modeling the human mind and you're trying to model it with algorithms and data structures. So you have the logic type of stuff like in a spreadsheet where it's just adding things. It's very regimented, and that was like early computers. And then more recently, you have these statistical things that can mimic the very organic process of how do you create associations. So a good example of this actually is you'll get those CAPTCHAs where it's like, prove that you're not a robot. And you have to pick out the bus or the boat or the tree or the traffic light. Why do they want you to do that? Because if they show millions of people, millions of pictures of traffic lights at every single different possible angle, and cars and trucks and boats at every single possible angle, they feed that into a computer and it learns by association statistical patterns. Oh, this is what a truck looks like. This is what a boat looks like. And it's each frame of the video that self-driving car sees, it's like, oh, that's most likely to be a traffic light. That's most likely to be a stop sign. That's most likely to be a car. That's most likely to be a truck. And so you feed the algorithm thousands and millions of examples of something, and it gets good enough at recognizing it that it can be useful, that it makes an error 1 in a million or 1 in a billion times. And so in the same way, when you're learning a new language and you're trying to say the word the right way, or you're learning new people's faces at the office, it takes a few times for your brain to like intuitively get it. And then you get it. And so in the same way, your brain has that organic process of coming up with whatever that is, that sort of intuition. And the machine learning side of AI is about capturing that same kind of intuition in a computer using statistical processes. It's important to understand those are the two key pieces, and any type of problem you're trying to solve with AI, you're figuring out, does it fit into this logic side, or I just need to write like a very complicated recipe, or it's kind of like the chef taking a little spoon and tasting and be like, put a little sprinkle more pepper or salt into that, and they're not even really measuring it, but they've got that sense of like, yeah, this tastes like grandma's tomato sauce, or tastes a little off, maybe add a little this, a little that. So those are the two different kinds of AI. That's the big split in the middle of the kinds of problems AIs used to solve.